In this tutorial, we will learn about the basics of C++ typecasting. Typecasting is nothing but converting one data type into another data type. There are two types of typecastings in C++. One is an implicit typecasting or implicit type conversion, or we can say is an automatic type conversion. The second type is an explicit typecasting or explicit type conversion, or we can say is a forced conversion. That one, first one is an automatic conversion, second one is a forced conversion. So why is it automatic conversion? Because the type conversion done automatically by the compiler. That's the reason why we call them as an automatic conversion or an implicit type or an implicit type conversion. So let us look at the following example so that you understand how the automatic conversion will be done by the compiler. So I'm going to open my text editor. As you can see them here, there is a basic boilerplate for the C++ program. Let me say I'm going to create a variable of type integer. So integer, I'm going to create a variable name. Maybe I would say number1, and then I'm going to assign the value for this variable, let's say 9. Now what I'm going to do, I'm going to create another data type. This one is not going to be an integer. Instead, I'm going to create a data type of type double. I'm going to call this variable name as a number2. Okay, so in this case I'm not going to assign any value for this data type double. I need the value for the variable number2. Then that value I'm going to get them from the variable number1. Now one thing that you need to notice here is this number1 is the variable name for the integer data type. This number2 is the variable name for the double data type. These two are different data types, right? Now what I'm going to do, let me just simply print the values. Cout, if you want to print, I'm sure that you know cout. The first value that I want to print them here is an integer value. So this is just a string or a message. Now where is the integer value? The integer value is stored into this particular variable name called number1. So if you want to get that value, so here you are going to say number1, right? Then I'm sure that you know, if you want to print the messages into the new line, you can use either /n or enddev. So in this case I'm going to use enddev. So in this first message, what are we trying to print? We are trying to print the integer value. In the second one, what I'm going to do, I'm trying to print the double value. So here double has the variable name as number2. At the moment number2 has got no value, but here we assign the value of number1 to number2. So here what I want to print them here is number2. Now let me run. As you can see them here, the integer value is 9 and double value is also 9. Okay, because we have managed to assign the value for this variable num1 to this variable num2. But if you notice one thing, num2 is a double data type. This num1 is an integer data type. But what we can able to see them here is both of them, they are integer data type. So in case, let me put it another way, like I'm going to say 9.0. Then here I'm going to say just a variable. So here what I'm going to do, num1 will get the value from num2 variable. Basically what I have done, this num1 is an integer data type but there is a no value. This num2 is a double data type but there is a value. Let me say this one is a 9.7 because this is a double value, or you can even say 9.76, whatever the value, because it's a double data type. So in this case I'm trying to get the value for this variable num2 and then I'm trying to assign that value to the variable num1. Now when I run this one, let's see how the result would look like. You can see them here. Now is printing the integer value as 9 and double value was 9.76. I hope one thing that you have noticed, before when I assign the value for the variable num1 and then I assign that value to the variable num2, both values they were 9, right? But here, how come this integer value, instead of 9.76, it has managed to print 9, not 9.76? What has happened? So basically here one thing that I want you to observe is the compiler is automatically converting the double data type into an integer data type. That is a reason why we are getting 9 instead of getting 9.76. But in the previous example, that thing was not happened because both values they are 9. Even the double values they are 9. There was no change there. Now what is the reason? As we have seen from the above example, the conversion from one data type into another data type is prone to data loss. When you convert the larger data type into a smaller data type, there will be a data loss. Now how are you going to know which data type is bigger than the other one? So the following is the correct order of data types from lower rank to higher rank. So this is a lower rank, this is a higher rank. So as you can see them here, in the first example, I was trying to convert the integer data type into a double data type, right? In the second example, I was trying to convert the double data type into a integer data type. So as I was saying, this order, this is a lowest rank, this is a highest rank. When you convert the highest data type into a lowest data type, there is a chances for you to lose the data. That is the reason why in the second example, instead of printing 9.76 as an integer value, we were able to print only 9, right? So in that case, there was a chances of losing the data. So this is how basically automatic type conversion will be done by the compiler. I hope now you have understood what is implicit typecasting or an implicit type conversion or an automatic type conversion. The next type is an explicit typecasting or an explicit type conversion or a forced conversion. So what does that mean? The name says explicit. So who is going to do the type conversion? This time the compiler will not do any conversion. Instead of compiler, the user or the programmer are the one who is going to do the typecasting. An explicit conversion allows the programmer to manually changes or typecast the data from one variable to another type. Hence, it is also known as the typecasting. Generally, we force the explicit type conversion to convert the data from one type into another type because it does not follow the implicit conversion rule. So that is the reason why we are doing explicit typecasting or an explicit type conversion. So in order to do the explicit type conversion, there are two ways that can be done. The first way is explicit conversion using the cast operator. The second type is explicit conversion using the assignment operator. Let us see one by one how a user can convert one data type into another data type using explicit conversion using the cast operator. The another type is using an assignment operator. Now let us start with the second type, name called assignment operator. Using this assignment operator, how typecasting can be done in C++. Then we will see the cast operator such as static cast, dynamic cast, constant cast and reinterpret cast in the next video. So now let me open my text editor. Actually in this program I'm going to show you the need of explicit conversion and how explicit conversion can be done using an assignment explicit typecasting. Okay, so here what I'm going to do, let me create two variables that of integer data type. So I'm going to say num1 and then I'm going to assign the value for this num1. So the num1 value can be anything. Let me say in this case 7. Okay, I'm going to create another variable. Let me call this one as a num2 and then I'm going to give the value as, let's say 3. Okay, now I'm going to create another data type. In this case, let me call this data type as a float. Then I'm going to create a variable as result. Okay, as I said, I'm going to show you the need of explicit conversion so that you can understand how to do the explicit conversion using assignment typecasting. So now what I'm going to do basically, let me just type the message in the cout statement. This is explicit conversion. I want to print the message in the next line, so I'm going to use the end of statement. So in the next cout, what I'm going to do, I'm going to divide the num1 value with num2 value. This is what I'm going to do. I'm going to say the result as a message attached to that division operation. So the result will be, I'm going to divide num1 with num2. Let me put the end out. So when I run this one, so you see the result is 2. But when you divide 7 with 3, the result will give you a floating point. In this case, yes, it's an automatic or an implicit conversion, but we are losing some value. In order to retrieve that value, explicit conversion can be used so that we don't lose any value. So how can we do explicit conversion for this one? So what I'm going to do, I'm just going to copy this line and then let me paste them down there. Instead of, sorry, this one is unfortunately is not an explicit, it's an implicit, right? So implicit means the conversion will be done by the compiler. Explicit means the conversion will be done by the programmer or a user. So here now I'm going to use an assignment type typecasting. So the syntax for that assignment type typecasting is this. So inside the parenthesis we are going to pass the type, then here we are going to have the expression. So this is a syntax for you to use assignment type conversion. So as you can see them here, type within the bracket, then expression. So here what is the expression? The expression is this. I want to divide num1 divided by num2. That is an expression, right? So in the type you are going to specify the data type. Now the result will be a float. So I'm going to have the type as float within this parenthesis, right? Now where do you want to store the result? I want to store the result here in this particular variable name called result. I hope everything is clear. When I divide num1 with num2, the result must be a floating point, but unfortunately because of the implicit conversion, what I am getting is an integer value. In that case I am losing some value. For us to not having that issue, we are going to follow the explicit conversion. Explicit conversion means a conversion that can be done by the programmer. So here I am specifying the data type as float, so that when I divide num1 with num2, that float value can be stored into this variable name called result. So here what I am going to do, I'm just going to copy this one and paste them here. So the result that I am going to display them from this variable name called result, because this variable now has the result of num1 divided by num2. When I save and run this one, you will see the implicit conversion has converted and divided the num1 with num2, and then it has produced the result as 2. In this case we are losing some value. To avoid that one, we have used an assignment explicit conversion. Because of that, we are able to retrieve the lost value using this implicit conversion. So this is how explicit conversion can be done using an assignment operator. I hope this one is clear. Now we are going to discuss about the different casting method and how we can do the typecasting using static, constant, dynamic and reinterpret. Let us see one by one. The first one is a static typecasting. Static typecasting is one of the explicit typecasting. With this static typecasting, we can perform all the conversions carried out by the implicit cast. Because implicit casting is done by the compiler, it will convert the one data type into another data type. Same thing can be done by the static casting as well. Maybe you might have a question here. If this can perform the same thing that the implicit casting can do, then what is the use of static cast? Oh, the answer is simple, because the static casting is a simple compile time casting that converts or casts one data type into another. It means it does not check the data type at the runtime whether the cast performed is valid or not. Thus, the programmer or a user has the responsibility to ensure that the conversion was safe and valid. So with this static typecasting, you can also perform the conversion between pointers of classes related to each other. So this is basically how static casting is being used when you want to convert one type of data into another type. If you want to use the static casting, here is the syntax. It will come up with static cast. Then here in the angle bracket you are going to specify the new data type, and then here you are going to have the expression. Remember, the first statement says it is same as the implicit casting. So what does that mean? Let me create a variable. So let me call this variable as multiplication, and then for the data type for this particular variable, let me say it's a double. Okay, now I'm going to assign the values to this variable. So multiplication, I want to multiply 3.6 times, let's say 1.7. Okay, now I'm going to create another variable with a different data type. In this case I'm going to say integer data type, and then I'm going to create another variable as a result. Okay, when it comes to the implicit data type, what does that mean? The compiler itself will convert one data type into another data type, isn't it? So for example, if you want to find out the result of this integer data type, it can be collected from this variable multiplication, isn't it? So let me just copy and paste. So what does that mean? These two numbers will be multiplied, the result will be a double value, but we are trying to assign that double value into this particular variable result, but this result is a type of integer. So if you want to print the result, what will happen? The result will be an integer, isn't it? So let me just type result as a message, then here what you want to print them is a result variable. Okay, let me save and run. You see the result is an integer type. So this conversion has been done implicitly. The same thing can be done using static casting. This static casting is an explicit casting, but I said if this thing can be done using implicit, why are we going for static? Because static casting is a compile time casting. So what is the use? It means it does not check the data type at the runtime whether the cast performed is valid or not. So is a programmer or a user has the responsibility to ensure that the conversion was safe and valid. That is the reason why we use static typecasting instead of using implicit typecasting. So now if you want to use the static typecasting, what is the syntax? Here is the syntax. So we are going to copy this, and then what I am going to do, here result, here I am going to paste the syntax or the keyword static cast, then followed by there is an angle bracket. Within the angle bracket, what are you going to say? You are going to put the new data type. So what is the data type here? The data type is an integer, because the multiplication results you want to display them as an integer value, right? So that one will be in the angle bracket. Then here in the parenthesis, expression. What is expression? Expression is nothing but the variable that has the value, right? So this multiplication, I need to put them in the parenthesis. So now I'm going to cut, paste them within the parenthesis. So when I save and run, this 2 is going to display the result as 6, just like the way that it has done the implicit conversion. But the benefit of using this one is because static typecasting is a compile time casting, so the programmer has the responsibility to check whether the typecasting that we have performed is a correct one or not. So that is the use of static casting, and it is more efficient than the implicit conversion, implicit typecasting, right? So this is a first type of explicit typecasting. The next one would be a dynamic typecasting. The dynamic casting is a runtime cast operator that used to perform a conversion of one type variable to another only on a class pointers and references. Don't worry about this class pointers and the references. I'm sure that you know about the pointers, where we use asterisk. Pointers is a variable that refers to the address of another variable. In case if you know C program before, I hope that you can able to understand what is pointer. So this dynamic casting is a runtime cast operator used to perform conversion of one variable to another variable only on a class pointers and references. It means it checks the valid casting of a variable at the runtime, and if the casting fails, it returns a null value. So the need of a dynamic casting is generally arises because you want to perform a derived class operation on a derived class object. Don't worry about this derived class and the base class, because we are going to learn about inheritance concept in the later part of the video. By then you will understand what is a base class and what is a derived class. Base class we can also call them as a super class. Let me give you this example. Base class is like your father, derived class is like you. So you will inherit the properties of your father, and then you can have your own properties and maybe your attitudes. Sometimes you might hear people saying that, no, you look like your father, your attitude look like your father. Yes, because you are the son. So sometimes you can derive the attitudes from the superclass or from the base class, as well as we can have our own attribute or maybe a properties as well. That is exactly what inheritance in C++. So the need of this dynamic casting is generally arises maybe because you want to perform a derived class operation on a derived class object. Let's look at this example code. If you don't understand what is going on, please don't worry, we will get to it later. So now I'm going to create a class. This is a syntax for you to use the dynamic casting. Dynamic cast Here you are going to have the new data type, and here you are going to have an expression. So this example we are going to learn it dynamic casting with a class and objects. So in order to create a class, you are going to use a class as a keyword in C++. Now we are going to give the class name. Let me give the class name as a base. It can be a super class. Okay, so this class initially I want to leave it blank, like I don't want to have any methods or I don't want to have any data types inside this base class. Okay, don't worry about this one. As I say that we are going to learn classes and object in details in the later part of the video. Now let's consider this is a base class or a super class, or you can call this one as a parent class. Now what I am going to do here, I am going to create a derived class. Derived class means a class that can derive the properties and methods from this class. So let's say I'm going to name that class derived. So you have to use class as a keyword. Let's say this is a derived class. So this derived class, where are you going to derive the properties and methods from? From this base class, right? So you have to put the full colon, and then you're going to use the access specifier. We are going to learn about the access specifier as well, so don't worry. So the access specifier would be public. Public means it can be accessed everywhere in the program. So public is an access specifier. Now I am going to write the name of my base class. I hope as for now everything is clear. Even within this class, I don't want to keep any data members or a member function. Data members are nothing but member function means, I hope you know functions. Same like if you want to perform a piece of operations, a piece of function, that can be written within that member function. Here we call them as a member function, just like the way that we call function in C program. So we have got two classes now. Now what I am going to do, I am going to write my main function. So I am going to write the integer main. This is my main function. Within the main function, remember, if you want to execute the program, everything needs to be called in the main function, right? Now this is a class and object. Now I have the class name called base. So I'm going to get the class name. Now I'm going to create the object for the class. Object is an instance of a class. Maybe in short I would say creating a variable for the class is an object, right? So this is a class. Now I'm going to create an instance for the class. So that one can be anything. So let me say in this case just B. So don't think that it has to be B. It can be anything, A, B, C, X, Y, Z, just like the way that you create a variable. Now we have two classes. We have got another class. I'm going to get that class, and then I'm going to create an object for this class. So let me call this one as a D. Now what I'm going to do is I'm going to create a pointer variable for the base class as well as for the derived class, and then I'm going to typecast them using dynamic casting. So for that, what I'm going to do, I'm going to pick the base class. The name of the class is base. I'm going to create a pointer variable. So when it comes to the pointer variable, you need to put the asterisk. Let me say I'm going to say this one as a BP, whatever the name that you want to give. Then I'm going to use the dynamic casting. So for that, what I'm going to do, I'm just going to copy this particular syntax. Then I'm going to paste them here, right? So what is the data type here? Data type is nothing but base. So here I'm going to say the base, and then it is of type what? Pointer. Then what are you going to pass them here in the expression? You are going to pass the object for the derived class with the reference variables. As you can see them here, this cast operator used to perform conversion of one type of variable to another only on a class pointers and references. So this is a class pointers. So what is the reference for this derived class? D. When it comes to the reference, what do you need to put? You have to put this ampersand and D. Now what I am going to do in the next step, I am going to create the same for the derived class. So here I am going to say derived class. I am going to create a pointer variable. Let me call this pointer variable as PD because it's a derived class. So pointer variable for the derived class, pointer variable for the base class. Always remember, your variable name has to be descriptive. It has to be a meaningful name, not just writing anything. You need to come up with a valid, a descriptive variable name, right? So derived class, this is a pointer derived class. Again here I'm going to use the dynamic casting. So let me pass this one. So I hope you have already guessed. Here what am I going to have? I'm going to have the class name as a derived, and then this one is going to be a pointer. Then what is the expression here? The expression would be the reference to the base class. So what is the reference to the base class? Is B. So this reference is for the derived class, this reference is for the base class according to the definition that we have for the dynamic casting, because it can be only used in class pointers and references. Now what I can do, maybe let me say return 0. What is this return 0? I hope you know what is this return 0. When you have the main function as a integer main, this one will always return something. That's the reason why we have the return function. In case if you have this function as a void main, there is no need for you to have a return, because void means nothing. Now is not going to return anything. But when you have the return function as integer, is going to return something. That is the reason why we have the return function here. Now when I run this one, there is an error here. So what is the error? So basically there is an error here. I have to remove this because it's just the name of the class. Let me save and run. Class base, I don't know why I put this one as for. So here just class as a keyword followed by name of the class, no parenthesis. Sorry, it was a mistake. There is an error here. It says expected initializer before dynamic. That's an error. So meaning this first task has been executed without any error, but this second task has an error. The error is this: expected initializer before dynamic cast. Right? This error has happened because this base to derived conversions are not allowed with the dynamic casting unless the base class is a polymorphic. So here what we are trying to do is we are trying to convert the base to the derived class, because this is a variable, this is a base, and then we are trying to convert them into a derived class. That is why it is giving us an error, because dynamic casting does not allow us to convert or does not allow us to derive base to a derived class. So this one is the object of the base class, and then we are trying to convert them into a derived class. So in dynamic casting is not allowed. If you want to get rid of this error, if you want to convert the base class to a derived class, there is a way. All you need to do is, this is your base class, right? Here you are going to have a polymorphic function. So when I say polymorphic function, all you need to do is, here you are going to have a whicho as a keyword, and then you are going to have any function. Let's say I'm going to have a function as void message. Okay, so inside let it be blank. In case if you want to access a base class from a derived class, all you need to do is this: you are going to have a polymorphic function in your base class. So in that case we can get rid of this error, then we can still able to perform the dynamic casting on a derived class. Now what I am going to do, now I have the polymorphic function in the base class. Now here I am going to make a few changes. So I'm going to just call this one as a PTR. Let me just give the valid name. So here instead of dynamic casting for my base class, what I'm going to do, I'm going to create an object for my derived class. So I'm going to say new derived. So what is this derived? This derived is a derived class. New is a keyword in object oriented programming that will allow us to create the memory for this variable that we have created for the base class. Now this base class pointer is pointing to the derived class, right? Now I have the derived class. Here I have the pointer variable for the derived class. Now I am going to perform the dynamic casting. Now dynamic casting can be done from the derived class to the base class as long as the base class is a polymorphic function. In this case the polymorphic function that we have them here is a virtual function. So here I'm going to say dynamic cast. What are we going to have them here? Derived class pointer. So here what are we going to have? Instead of b, so even let us just get rid of this point because we no longer need them, because we have just created the base class pointer. So here I'm going to pass the pointer, base class pointer value. So what are we trying to do them here? We are still taking the base class and trying to convert them into a derived class using dynamic casting, right? So what is the next step now? So let us do one thing. I'm going to write a if condition. If this PD, I mean PD is a pointer to the derived class, is let's say not equals to now, then we are going to perform, let's say, let me just print the message. Here we can say dynamic casting is done successfully, right? Or else maybe we can write a else condition. Let me copy and paste. Is dynamic casting has failed, something like that, any message. Don't forget to put the semicolon, otherwise it will throw an error. So what have we done so far? Here we have managed to convert the base class into a derived class object using dynamic casting. So basically, what is dynamic casting? It is an attempt to convert an object into a more specific object. So when I run this one, what do you think? Is going to execute this statement saying dynamic casting is done successfully. That's what I'm expecting. Dynamic casting is done successfully, just because we have managed to convert the base class pointer to a derived class object. So this is how dynamic casting can be done in C++. Reinterpret casting. Basically, this is used to convert a pointer of some data type into a pointer of another data type, even if the data types before and after conversions are different. Remember, it used to convert a pointer of some data type into a pointer of another data type. That is what you need to understand here. I will show you with an example so that you understand. The next point is, it does not check if the pointer type and data pointed by the pointer is the same or not. So the syntax for the reinterpret cast is this. Reinterpret cast. Here we are going to have the new data type. Inside we are going to have the expression. Let me show you this quick example. So here what I'm going to do, let me have the main function. So within the main function, I'm going to create a pointer variable, because as you can see them here, it used to convert a pointer of some data type into a pointer of another data type. Let me say I'm going to create a pointer variable. Let me say integer. The pointer variable I'm going to say ptr equals, I'm going to assign this one to an integer. Okay, so in that case what I'm going to do, I'm going to say new integer. Now I am going to pass the integer value, let's say 10. Okay, now what is this one? This one is a declaration of the pointer variable. In the next step, what I'm going to do, I'm going to use the interpret casting operator to typecast the pointer variables. So for that, I'm going to take the data type as a character, and then stu is going to be the pointer variable. So I'm going to say ch. Now I'm going to use the syntax for reinterpret operator. So the syntax is this. Let me just copy and paste. So here the new data type is a character. So here I'm going to say character pointer. Now the expression that I want to pass them here is this particular pointer variable. So here I'm going to say ptr. What I have done exactly here is the first step that you can see them here. It used to convert a pointer of some data type. So this is a pointer of integer data type into a pointer of another data type. So this is a character pointer variable. So now I am trying to convert the pointer of integer data type into a pointer of character data type. In that case, we can use reinterpret casting technique. So now what I'm going to do, let us just display. For display, I'm going to use cout. So what I want to display is, let's say, the value of ptr. The value of ptr, where are we going to get the value of ptr? From this pointer variable, right? So for that, let me just say I'm going to get the name of the variable, pointer variable, that one. Then I'm going to use the end of statement so that next input will be printed into the new line. Then the next one, what I want to print is, I just wanted to print the value of this pointer variable ch. So let me copy and paste them here. So here what I want to print them here is a ch. So even here is going to be ch. Now what I'm going to do, I'm going to write the printf statement for the value of the defined variable using pointer. Now this is simply a variable. Now I want to print the values for the pointer variable. So let me copy and paste them here so that we can just change around. So here I'm not going to get the value for the normal variable. Now I want to get the value for the pointer variable. Even here I'm going to put the pointer variable, so that we will see whether the typecasting have done or not. So even here going to use pointer, even this one is going to be pointer. Basically, as I said, we are going to convert a pointer of some data type. In this case, that some data type is an integer, this is an integer, to a character pointer data type using reinterpret casting. So when I run this one, so what is this one? This one gives the address of the pointer variable, but unfortunately I can't see the value for the ch because it's a character, meaning we have to print the equivalent ASCII value. So I think for the 10 there is no ASCII value, no wonder that it's not displaying. So let's say I want to put maybe 65. So what is the equivalent ASCII value for the number 65? I think uppercase A, right? So in that case, the first ch is supposed to print A. In the second ch, again is supposed to print the A, right? So let me run this one. Yeah, exactly. So as you can see them here, when you print just this pointer, first we are trying to print the ptr. This ptr will print the address of this particular variable where we are going to store this value 65. Then in the ch we are going to print the equivalent ASCII value for this integer number 65 because of this particular typecasting that we have done them here. In the pointer variable, we are going to, here there is a pointer. Pointer means is going to display the value that were stored into that particular memory address. In that case, what is the value? 65. This 65, in short, this 65 value is being stored into this particular memory address. Now this ch is an equivalent ASCII value for the number 65. Then this pointer will specify the same ASCII value because we have already typecasted using reinterpret typecasting. I hope this one is making sense. This is how reinterpret typecasting would work. So when to use this reinterpret typecasting? When you wanted to convert integer types to a pointer type and pointer type to an integer type, we can use reinterpret typecasting. Another scenario where we convert one pointer type to another pointer type. The one thing that you need to remember here is misuse of reinterpret cast operator can easily be unsafe. Unless the desired conversion is inherently low level, you should use one of the other cast operators such as static, constant or dynamic. The reinterpret cast operator can be used for conversions such as character pointer to an integer pointer or one class pointer to a unrelated class pointer, which are inherently unsafe. The result of a reinterpret cast cannot safely be used for anything other than being cast back to its original type. So this is all you need to know about reinterpret casting in C++. Now we are going to learn about the constant cast in C++. So what is constant cast and what is the use of constant cast? Constant cast is used to change or manipulate the constant behavior of a source pointer. It means we can perform the constant in two ways. First one is setting a constant pointer to a non-constant pointer, or we can delete or remove the constant from a constant pointer. So basically the main use, a main purpose of this constant cast is to cast away the constantness of a variable. Let me show you this example. I don't want to confuse you much with the theory. I hope with this example you can able to understand how to remove the constantness of a variable. So the syntax for the constant cast is this. We are going to have the keyword as const cast. Here we are going to follow the new data type. Here we are going to have the expression, just like other casting techniques. So here what I'm going to do, I'm going to have the main function. So within the main function, let me say I'm going to have the const variable. So const variable means, constant means you cannot change the value. That is what it means. When you declare a variable with a const, you're not allowed to change the value. So here using the constant cast method, we are going to access, or we are trying to change the value of that particular variable to remove the constantness of that particular variable. So const is a keyword, I'm going to declare integer type data with a variable name called num1, and then I'm going to assign the value to this variable as, let's say, 40. In the next step, what I'm going to do, I'm going to create another const pointer type variable. Let me call this one as a int num, maybe the variable name is num2. As I said, is a pointer, so I'm going to add the asterisk in front. Okay, then this one I'm going to set is equals to address of the num1 variable. So what does that mean? This pointer variable num2 is going to have the address of this particular variable num1, right? In the next step, what I'm going to do, maybe let us do the typecasting now. If you want to do the typecasting, what you need to do, before we do the typecasting, what we can do, we can create a separate function, so that in that particular function we pass this constant integer num2 as a parameter. I'm going to create a function, so I'm going to call this one as a void function. In this void function, I'm going to pass an integer pointer value as a parameter. So integer pointer, and then I'm going to pass ptr as a parameter. So inside, what I want to print them is, let's say I just want to print the message of this parameter that I have passed them here. In this case, the parameter is a ptr. Okay, so let me just put enter. So we need to call the function. Since we have the function, I'm going to call the function. Within the function, what I want to call them here is this num2. Now I'm taking the value of this variable and then I'm passing that one as a parameter. So whatever the value that was stored into this pointer variable will be passed here as a value. Now the problem here is, this is not just a pointer variable, but this one is a constant pointer variable. So you cannot just pass the constant pointer variable as a parameter to your function. In that case, we need to typecast to cast away this constantness of this particular integer pointer variable. For that, we are going to make use of this particular syntax to cast away the constantness. The new data type, what is the data type? Since it's an integer pointer, because the parameter that it's looking for is an integer pointer, right? So this one is also going to be an integer pointer. Which one are you going to cast away now? You're going to cast away this particular variable, because this is a variable that you're going to pass them as a parameter, right? So in the expression, this is what I want to typecast. This is a variable that I want to typecast. Now I'm going to store this one into another pointer variable. Let's say I'm going to cast away with this one with another pointer variable. So now let me call this one as an integer, because I'm looking for an integer parameter here. Then it's going to be a pointer variable. You can name them as any, like in this case I'm going to say new, right? So in this step, for example, if I save and run, since it's a void function, so this main function is going to return void, because it's a void function, is going to return nothing. So in this case, when I run this one, you will see an error. It's not just because of this semicolon here. Let me save and run. There is an error here, because what we are trying to do, we are trying to pass this num2 variable as a parameter to this function before we typecast. It's failing to accept just because we have not typecasted. So we are trying to pass this constant behavior of this particular variable as a parameter to this function, right? I hope it's clear. Now what you need to do, first you need to typecast, then you have to pass the value as a parameter. So this step I'm going to cut. First I need to typecast this variable to an integer. Now that typecasting is being stored where? Into this new variable name called new. Now I'm going to take that new as a parameter. Oh, new is a keyword. No wonder that let me put away new value. Remember, you are not allowed to use the keyword as a variable name. That's the reason why it's giving me an error. This is a num1. This one num2 pointer variable will store the address of the num1, though these two are the constant variable. This function is simply looking for an integer pointer variable value. So in order to remove the constantness of this particular variable, I need to typecast. The typecasting method here I'm going to use them is a const cast, right? This const cast, what do you want to convert? This one is looking for an integer pointer, so the data type that I want to convert is an integer pointer. Which one are you likely to convert? I want to convert this particular variable. That's the reason why I took this variable. Now I am going to store this one into a new variable. Now I am going to pass this new variable as a parameter. So when I pass this new variable as a parameter, the constantness of this particular variable has been removed. So it is just going to display the value as 40 when I run this one. So when I run this one, I'm sure that it is going to display the result as 5. What is the error? Was not declared in the scope. So maybe let me just declare a function. The function is a void function and then it's of integer pointer. Let me save and run. Oh, so this one is an end L. So save, run. I'm sure that it will run. And the result is 40. Initially this 40 belongs to this constant variable. Now because we have managed to typecast that constant variable, just to remove the constantness of this particular variable, now we are passing that value as a parameter to the function. Now we can still able to print the value. This is how const casting will be used in C++ to remove the constantness of a pointer variable. I hope now you have understood all the typecasting techniques that are found in the C++.